Hello everybody, welcome back into this third video on setting up the Siemens ET200 for a template from which tasks associated with the automation disciplines of world skills can be developed. Again, this is focusing primarily, fully actually at this stage on the regional round of the competition, not on the national finals. We will develop this template into a finals series template in a later playset, our playlist after we get this one sorted out. So in the last video, video 2, we finished up on this screen in which we created the CP interface, the cyber physical interface, and we also mapped the inputs and outputs at these cards into the code via that CP interface. So if you didn't see video 2, please do go into video 2 and look at it, because it is a necessary prerequisite before you start into this video. And indeed, if you haven't seen video 1 in this playlist, you must go and look at that because this playlist is building this template up step by step. So if you've missed an earlier step, you're not going to fully understand the steps that are happening subsequent to it. So I'm going to start off this video here with making changes to my UDT. If you recall from video 1, when we founded these UDTs, we give very generic simplified names or tags for these, and hopefully in video 2 you can understand the reason for that, where it just left the mapping an awful lot easier. But in this one, I'm going to do now is I'm going to move on ahead and I'm going to rename these to tags, or give them nomenclature that is more indicative of the types of devices that you're going to be encountering in automation at the regional finals. So the way I do this here is that if I'm dealing with two digital input cards, I'm dealing with my inputs here in my UDT, two digital input cards, input card 0 and input card 1. Input card 0 has 8 pins to it, so it is 8 bits, and what I put onto input card 0 is typically going to be inputs from devices that are located down on the Festo profile plate upon which we mount our cylinders and our equipment. And then similarly on my second input card, which is input card 1, or data byte, or byte 1, input byte 1, I'll typically put inputs in from the devices and the boxes that exist above that, which are typically buttons. So in IP0, this is nomenclature I use. I use an X to identify this in code that this is Boolean. I use L for limit, 0 for zero limit, fully retracted limit, i.e. zero distance, cylinder A, XLOA. Next one, XL1A. Right, so why do you start with extended before you start with a retracted limit? Well, from my perspective, it makes sense to me to read from left to right. So when I'm looking at a profile plate, everything that I try to teach and everything that I try to promote has a left to right flow, unless it's specified otherwise in the circuit requirements, where you might have to extend, vertically or that. But other than that, always make sure your flow goes left to right. So if you look at a cylinder on that plate, the extension is usually to the right of the retraction. So if the cylinder starts retracted, in its normal state, the left-hand side device, whether it be a roller switch or whether it be a cylinder-mounted mag, is typically mounted to the left. That's the zero limit. That's the retracted limit sensor or switch. That's left, so that comes first. And then as you move to the right, you encounter the one on cylinder A that deals with the extended limit. And A is on the left of B, because we're going from left to right, A then to B. So for that reason, I'm going to go for XL0B comes after that, XL1B comes after that. Let's go for a third cylinder, XLOC, XL1C. This one here, I'm going to, this one, I will give another input into this one, and what I typically put onto these ones is going to be my pressure sensor onto this. So it's not always called up for, but I like to keep it in there. Right, I put it in there for the fact that you might have a pressure build on your PLC. So let's make sure that we have an input in our template that's going to monitor that pressure build, and send a trigger there, obviously, when the pressure is at the specified or the set point value. The last input on this card I'm going to put in as a spare, right? So I'm going to go X spare, right, IP input, and I go for 1. Now I'm on to my second card here, right, or card 1 or byte 1, which is the second card that I have of inputs. As I said, in byte 0, the first card, these are input devices, sensors and whatnot, pressure sensors, anything there that I'm going to mount onto the profile plate down low. On my second card, this is anything there that I'm going to take information and inputs into the PLC from a device that's mounted above the profile plate, which typically are my buttons. XPB1 is my DDAN, XPB2 is my first momentary, XPB3 my second momentary, XPB4 there's my third momentary, and the 4th switch. Okay. What I'll also have in here would be an e-stop for the most part, but I don't tend to put it into here. I will use this as X spare underscore IP2. Second spare input, do not use, is there for a reason. Do not use it. But down here, what I'm going to do is put in my X e-stop. Right. You may not have an X e-stop, you may not have an e-stop specified, but you might, put it in. Increasingly, in world skills, you are having e-stops, and not only that, you're having XSLC, safety light curtain signal. 2 safety devices on there. Okay, so the finals, the UK finals, the last couple of years, last 2 years, is it 3 years now? Have safety light curtains on them. Now, they haven't come into the regional finals. The e-stop might. There's increasing amount of hard wiring off of the Edu Trainer standard kit, and the e-stop might come into that, fairly regularly. But you'll also might be asked to mount separate buttons, reset buttons, and all, and that's what these spares will typically be there for. So even though you're not likely to use safety light curtains in the regionals, we're going to keep it there anyway, because it's unlikely that you're going to have 16 inputs in the regionals and that you'd otherwise need that slot for something else. So we'll put it there because it will reduce the amount of changes we need to make as we adapt this regional template for a nationals template. So these changes have been made in the UDT. So make sure it's in the UDT, you make the changes. Not in the PLC tags, not anywhere else. It must be in the UDT. Right? So them changes are made. And what we're going to find here now is that when I look at anywhere where this UDT has been referenced, I'm going to have a pink field. This is the first place it's been referenced. No, it's not. It's filtered through in that because it's addressing it through. Where I've wrote it in for code, for instance, in my data, we see the pink field there, right? Because this is still registering the old DNA that was written in. Now we have changed that slightly, and it doesn't recognize that there's a difference, and it's prompting you there to say that it's been changed. So we'll see it there. You'll see it in the CP interface itself. Up here, let me drop down that there. You'll also see it out here. Well, maybe not, but anywhere there where that's that's referencing data that's stored in the UDT-DI. Once we've changed it and there's a mismatch, we're going to get that pink field. So how you get out of that is just again click onto your PLC folder, click compile, and that's the job done. So again, referring back, CP interface, that is now gone white again, and my data, that's gone white again, and indeed, have a look, everything's been properly updated. Indeed, in the CP interface yourself, we can see it in here as well, that because I changed the UDT, all my names in here have automatically updated. No, there's no need to change your names up here into XLOA, XL1A, no need. Those are just placeholders there. We'll never refer to them ever again. They're just there to help us address. Okay, so what I'm going to do now is I'm going to make the same changes for a similar reason, changes to the UDT. Again, the UDT DQ my digital outputs. So again, the first card on my digital outputs is Q0, so it's Q byte 0. And again, this is a left to right structure. So if I look at my directional control valves that are mounted on my profile plate, I'm going to have terminal 14 to the left and then terminal 12 to the right for cylinder A. Terminal 14, sorry, to the left, terminal 12 on the solenoid of the directional control valve for cylinder B, and so on. Terminal 14s are your extension. Solenoids. So I've come to the left and I see cylinder A, X, A, right? E, X, T. X, A, R, E, T, retract. X, B, E, X, T. X, B, R, E, T. X, let's go for C. E, X, T. X, C, R, E, T. Now, I'll likely in the region or in the nationals, not again in the regionals, but again I'm going to get it tight to fill up all these outputs in the regional. So instead of writing spare, I might as well write in something that is likely to be useful to me. I will also have X air sup. Right. What is that there? That's a 3-2 that'll typically use to switch air on and off to the to the board itself. So for instance, if I hit an E-stop, I might want to drop off all the air supplies. So I might want to cut power to this X air supply. My last output on my first byte, my output byte, is going to be a spare, X spare underscore OP1. Now I'm on to my second output card here, my second byte, which is byte 1 for my outputs, right? And where these here all are typically found on the profile plate, these are typically found up high. What gets up high on the outputs is usually your lights, XLGT for PB1. So each button on the EduTrainer button box has a backlit coil as a light in the back, and that's what these here are for. LGT PB2. Why LGT before PB1 light or that? It's because whenever I'm typing in my code and I'm looking to filter down through my results, I can just put in XLGT and it'll bring me up all my options for lights. If I put in PB1 light, I put in XP, it'll bring up, sure, PB1 light will get brought up, but what will also be brought up is the likes of X pressure or X anything else that starts with a P. So LGT just lets me know that I'm dealing with all my lights here. In a similar vein there, SNR I'll use for sensor. So I'll type in X SNR, that'll bring me up all my sensors. So I have more lights here that could typically be included, which would be XLGT red, XLGT amber, XLGT green, of course. Right. So what other outputs might I have in there? Well, we could probably maybe output to a signal, maybe out to another PLC. But for now, we have a second spare. Spare OP2. Done. So again, we've changed the UDT, and what that's going to look like here is a red field for the EQ. I'm going to click onto my PLC folder, click compile, and that gets that sorted out. Right, the next step on this is I'm going to set up write up a new function here. And this function here is going to be for outputs first. Outputs. Now I'm going to put outputs hyphen safety underscore DEPT dependent, safety dependent outputs, SCL function, okay. Now what does that mean? Well, it means here that, well, I'm going to set up two, give you a wee bit of foresight, I'm going to set up two functions for outputs. One is safety dependent, one safety independent. Safety independent are I'm going to write code for outputs that I want to be scanned all the time regardless of what state of safety that the PLC is in. So if the PLC is reading that the system is safe, it's scanned. If it's reading that it's unsafe in a safety independent block, it'll still read them. So lights are a typical thing that you'd put in a safety independent block because you want the lights maybe to operate if the system is safe or otherwise. Maybe you have an unsafe light. It obviously cannot be switched off if the system becomes unsafe. However, for the likes of your actuators, actuator A, actuator B, actuator C, whatever it may be, things that are moving, when you hit an e-stop or you break a safety light curtain or you trigger a door interlock or whatever it may be, maybe you want all them outputs to stop actuating. You just want to drop the block off, freeze. Now you can cut the air off, absolutely, but you might also want to switch off your solenoids. Might want to switch off any sort of power going to these, and that's why I'm going to write up a safety dependent function here. This safety dependent, I'm going to put in all my actuators that if the system becomes unsafe, I'm going to stop scanning this particular function. I never write for any function that I'm going to write from here on out, anything in input and output, that's only for the CP interface. In out, yes, absolutely. I need to be able to write out a function for our commands to my DQ. I need to populate them with UDT DQ. And I also want to know about sequence data. Sequence data for sequence 1, because there's going to be actuations to to make sure that the sequence laid out in sequence 1 is executed. UDT sequence, that's where all that stuff's stored. Sequence 2, and say let's go for sequence 3. So we're going to go for 3 sequences in here. Right? That's really all I need to know just for now. I'm going to scoot this on up. Let me zoom myself in. I'm going to put in a region. This here is going to be for actuator A region. And in the statement, just to give an idea for the template, so I'm going to say template gives as if actuator A is controlled by a YA. Y is my letter for solenoid. So YA is solenoid actuated / SR spring return DCV. Right. So maybe actuator A is going to be controlled by a solenoid actuated solenoid return, but I'm going to set up the template as if A is controlled by a spring return, just so in the template we have a structure, a coded structure that gives code, how to write code in an eventuality that some actuator is spring returned. Now, I write all these here in ifs. I think the vast majority of people that I've ever come across in Morris skills always use case statements. I'm not a big fan of case statements. I think they're very limited. The if statement gives you full logic control and full flexibility, and it's very quick once you can understand the logic that the if lays out. All right, so I'm going to put in if. Now I'm going to put in a comment in here. Right, so this is going to be code for extending cylinder A. I change code to conditions. Conditions for extending cylinder A, for extending and keeping extended cylinder A. Just write that in. And maintaining cyl A extension. Right? I'm going to change that cylinder back to cyl. Now, what do you mean maintain a cylinder extension? Well, if it's controlled by a spring return DCV, it means there that the spring is always looking to return the cylinder, or return the valve to its non-actuated state till it's off the shelf state. If the cylinder's initial position, home position, is in retraction, the spring is holding it in retraction. The only time it will not be retracted is whenever you power up, solenoid terminal 14 of that solenoid. That does two things. It extends the cylinder by shifting the spool in the valve to let air out of port 4 up to the cap end of the cylinder, but it also compresses the spring. Now, if I let go of that, right? The spring is gonna decompress. It's gonna go back till its neutral state, and it's gonna shift air back. It's gonna shift the spool back over with it in the DCV, and the cylinder is gonna kick back into its retracted state as the spool will now let air out of port 2. So I not only want to extend it maybe in step 10, but maybe I want to keep it extended until it's time to retract. Maybe it doesn't retract until step 100. So I need to keep power on it from step 10 all the way up to step 100 and then let go in step 100. So then it retracts. Right? That's the idea behind the spring return cylinder. That's why I'm writing up a separate section of code for it. So if, so I'm going to go for sequence 1 dot W step is greater than or equal to. Now I'm just pulling out numbers here. Greater than or equal to 10, and sequence 1 dot W step is less than, just again pulling out numbers for the sake of them. Okay, so if that, or I'm going to put in another condition in sequence 1, or if sequence 1 step is equal to, who knows, maybe 70, and it's less than 100. Right? I'm going to make a set of conditions here, not only for sequence 1, but even for sequence 2. 2, 2, 2, and 2. Right. And that's also for sequence 3. Now again, 100, let me see what I've done here. Or put another space, sequence, don't know what happened there, sequence, sequence 3 dot W step. Put a space on that. There we go. Apologies for that, everybody. 3, 3, 3. So if sequence 1 step is greater than or equal to 10 and less than 40, or sequence 1 step is greater than or equal to 70 and less than 100, or sequence 2 step is greater than or equal to 10 and 40, and so on, if any of them things are true, right, I want, apologies, let me go make sure I have it right, then what do you want to happen? Well then, dq dot a extend is set to be equal to true, but if it's not, else dq dot a extend is false. And if, that's it. So for these conditions, I want the cylinder to extend. I want A to be in an extended state. I want to power up the solenoid to extend A. But if none of these are true, for instance, if I am equal to 40, then I want that cylinder to be off. I want to de-energize. I want to make sure it's not energized. Terminal 14 of that solenoid. Okay, so 40 is false. So that's what's going to set out there. That's in a solenoid actually a spring return. Now notice I haven't wrote anything for a ret. There is no a ret in a spring return. Right? There is no a retraction. The question is, well, how come you have an a ret there? Do you not take that out? No, don't take it out. You leave it there. You leave it there because as soon as you take it out, then what you've done is you've created an inconsistency. The idea in this here is that if you're training a team or if you are a team watching this, typically you'll have one person's going to be coding, one person's going to be building, but you both need to know the order of how you plug in to each of your to each of your inputs and your outputs, and you need to know how they're coded. You need to know that this is A extend, A retract, B extend, B retract. B extend is always in percentage sign Q 0.2, always, right? If you take this out here, right, then why not move B extend into here? Well, now B extend isn't in percentage Q 0.2, it's in percentage sign Q 0.1. It's inconsistent. It changes from task to task. You do not want that. You keep the consistency there, right? If it's there or not, that terminal is reserved for that output. right? You mightn't just wire till it, but it is reserved for that output, right? That's actuator A. That's the way that's going to be set out if it's a case that we have a solenoid actuated spring return. Now, we might also have which we will, well, maybe not, a solenoid, this is actuator B, a solenoid actuated solenoid return DCV. Conditions for extending cylinder B. I mean, right? There's no maintaining the extension now because there's no spring to take it out of extension. I just give it a pop of power into the valve. It'll shift the spool over. It'll let air out of port 4. The cylinder will extend, and I take power off of terminal 14 of the solenoid. The spool stays where it is. There's no spring to kick it back, so it just stays there, and air maintains the pressure is maintained through port 4 into the cap end of the cylinder. The only time there it retracts is when I give it a pulse out till terminal 12 solenoid, and the spool shifts over and lets air out of port 2, the direction control valve, and shifts it back. Apologies, just popped off there for a supple LEMSIP. So yeah, what was I saying? Yeah, so for cylinder B, whenever we give a pulse until port 12, terminal 12 of the solenoid, it'll let air out of port 2 of the valve, and it'll retract the cylinder. So that is likely to happen in one of our cylinders to be controlled by a solenoid actuated solenoid return valve. So for extending and retracting B, I do not need a greater than or equal to, right? All I need here is just my equals to. There is no ands here. There is no range. I just want to extend B if sequence 1 step is equal to 10, or if sequence 1 step is equal to 70, or if sequence 2 step is equal to 10, or if sequence 2 step is equal to 70, or if sequence 3 step is equal to 10, or if sequence 3 step is equal to 70. If any of them things is true, if I'm in sequence 1 and I'm equal to 10 or 70, if I'm in sequence 2 and I'm equal to 10 or 70, 3, 10 or 70, then I want B extension to be true, right? But I also want dq dot x B retract to be false, right? So now it should naturally be false. It should be off anyway, but I'm going to write that in just in case, okay? And I'm going to take this. So there is no else here because everything else is true. And I'm not saying I want this to be firing in retraction for all other states. That's not right. Because if I say, for instance, want to retract this in step 40, right, and I left that in there, that would retract in step 20 or 30. That would retract in all other steps other than 10 and 70 in sequence 1, 10 and 70 sequence 2, 10 and 70 sequence 3. So that's not what I want. So I'm going to change that else to an else if. So this is another condition. Now you can write this up as a separate if statement if you like. I just tend to keep them together. Right? So this is else if. And in this one, I'm going to say conditions for retracting. Retracting cell B. Right? Extending and retracting. And I'm just going to scoot these over. Just for the speed, this sequence. I'm just going to move these because obviously it's not going to extend and retract in the same step. Number lock. I'm just going to move them up by 20s, 30, 90. Why? Just to put numbers in, placeholders, that's it. These are more than likely to change. You'd be massively fortunate if these actually match up to the sequence that you're asked to do. So yeah, these are just placeholders very simply so we can compile this and download it in. Now, this is the conditions for retracting. So I want retract to be true and extend to be false. Phenomenal. That's that. Now, next question, let me just scoot this down, is what if you have actuator A and B, and it says in the task that actuator B actually has a solenoid actuated spring return valve, and actuator A is the one that has the solenoid actuated solenoid return valve. Well, that's easy. If I want actuator A to have a solenoid actuated, or cylinder B, say here, I'll just do it this way, cylinder B to have a solenoid actuated spring return valve, right? You can change it there if you want, but that has no bearing on the code or the execution of the code. All I'm going to do is change that A to a B and that to a B, and that's it done, right? I'll put that back to A for now, right? And similarly, if actuator A is controlled by a solenoid actuated solenoid return valve, right? I just change all these here. X's, change that to an A, A, and A, and job's done. Right? So it's massively fast, massively quick. But again, maybe it's easy for me to say. When you know the code, you can navigate it very quickly, and you can understand its execution. It does become fairly handy. Okay, now we can put in actuator C. Now, how do you want to put in an actuator C? Well, actuator C, well, what's it typically going to be? The only change to that is that you might have a solenoid actuated spring return to center valve. But if you have a spring return to center valve, you're in a neutral position. It's not going to retract the cylinder that should otherwise be extended. It still will stay extended, so it still will behave as if actuator B behaves. Okay, so just for thoroughness, we'll just throw it in like this then. So C, template gives it as if actuator C is controlled by a YA, which is a solenoid actuated spring return, say in center. I'll actually write it in as a 5-3. So when you see the 3, you know it's a center one. DCV. So you're still going to extend in these. In 10, you're gonna scoot it on, and then it's gonna arguably, when it hits 20 onto the next one, snap itself into the neutral position, which is going to lock air off of port 4 and port 2, so it should stay where it is. Right. I did always write these up here with ranges. Anytime that I had a spring, I did use a range in it. It's going to change all my B's to C's, but just what I'm thinking now, it's a while now since I wrote these up from the start. My own templates use a range, but I can't see the reason why I would have a range in it, other than the fact that it is a spring. But given that the spring snaps back to a neutral position, we should be, it shouldn't act untoward. It shouldn't retract cylinders that otherwise should be extended, and vice versa. All right, there's my my safety dependent devices on these here, right? So I'm going to X out of that. That's really all I have safety dependent as devices. Now I'm also going to have safety independent devices, but we are up to 32 minutes on that. So what I'm going to do, I will come back in the next one and do a safety independent, and hopefully there'll be a little bit less explanation on it, albeit that our lights the way I set up the lights is slightly different. But to finish this one off, what we'll do is come back into the main OB. In network 2 is usually what I reserve for my management block, but what I will do is just to finish it off, as I said, I'll just bring this in. Outputs, this is going to be safety dependent. Right, safety dependent, let's drag that in. Right. So DQs, all these always get mapped back to the filing cabinet, my data DQ. That's what you need to write to. This is my data sequence 1. All these were created in the last video. My data sequence 2, and of course my data sequence 3. Done. That's where they get all mapped to. Now these are safety dependent, so what I'm also going to do on this one here, right, is I'm going to bring in a comparator function. I'm going to write in a comparser in here, right? And what I'm going to be looking for in this one here is going to be, I'll write it up here. I want to read the state of my data dot management dot safe status. Now I'm going to take off them commas and just write in like that. It sees it as being a string. So if it is safe, you'll be able to read that there. Let me just double check that again. That's not a double quote. I think it is a single quote for, yeah, single quote, inverted comma for TAA. So, so long as management safe status is given as safe, I can read that. But as soon as that becomes unsafe, there's a condition there, or well, anything other than safe, I'm going to stop scanning that block. Right, so that's what I mean by safety dependent. And then likewise down here, what I'm going to have is just an outputs, which is going to be safety independent, which will not have that check, in the string in this rung going forward into the block. Okay, so we wrote up a new function. Let's compile this, make sure we have no errors. So we have no errors, no warnings, everything looks good. Let's hit save. And that's our first little section of code for the functional section of code for this template written. Okay, so I hope everybody followed that. If you had any difficulty or any sort of misunderstanding or getting difficulty understanding anything I did, as always, just drop something there into the comments because I will be reviewing them. If you have any suggestions, any other experiences or anything with respect to writing in SCL or setting up these templates, absolutely shoot me a comment there as well. Let me know what you think. And again, if I don't hear from you, I hope to see you in the next one. And yeah, thanks very much for tuning in. See you then.